Unit 3, Formative 3, Day 2, Elimination Day 1. Okay, so we have learned about graphing and how to solve a system using graphing. We've learned about using the substitution method. Okay, the last method that we're going to learn of how to solve a system is to use elimination. Elimination is when you eliminate one of the variables. Okay, so let's talk about what it would mean to eliminate something. How would you eliminate positive 2x? What could I add to 2x to make it go away? Well, you'd add the opposite, or in other words, you would add negative 2x, because 2x plus a negative 2x is 0, so they would cancel each other out. Okay, so that's our goal, is to have them opposite. So what could we add to negative 3y to make it go away? Well, you could add a positive 3y, because negative 3y plus 3y is 0. Okay, what could you add to x to make it go away? Well, x plus negative x would be 0. Okay, so if you look, you want the numbers to be the same, but you want the signs to be different, because you want one of them to be positive, one negative, so that way when you add them, they cancel each other out. Okay, so that's what we're going to do to use the elimination method. So it says solve the system. So number 1, you have x plus 4y equals 9, and you have negative x plus y equals 6. So first things first, you can still look for a variable to be by itself. Okay, is there a variable by itself in this? No, there's not, which means substitution really is not going to work very easily. So we got to learn a new method called elimination. Okay, so you want to look for, do you have any variables that will cancel each other out? In other words, do you have any that the numbers are the same but different signs? So for the x's, you have a 1 and a negative 1. For the y's, you have a 4 and a positive 1. Well, the x's will cancel out because 1 plus negative 1 goes away. So what we're going to do is we're just going to add our equations. Okay, so I just put my line underneath, I put plus because I'm adding. Well, 1x plus a negative 1x cancels. Those are gone. That's the point. We eliminated the variable. And then we have 4y plus 1y, which makes 5y, and 9 plus 6, which makes 15. So now if you look, since we used elimination, we eliminated the x, which means we only have y left. Now we can solve this equation. So we can divide by 5. You get y equals 3. Okay, so remember then once you have your y equals 3, that's not done. I have to plug that back into one of the equations. Does it matter which one I plug it into? No, it doesn't. I just try to figure out which one looks maybe easier. It really doesn't matter. I'm going to actually plug it into the bottom one. So that one is negative x plus y equals 6. Okay, so we're substituting 3 in for y. So we get negative x plus, instead of y, I have a 3 equals 6. Then you just need to solve, so subtract 3 from both sides. So negative x equals 3, divide by negative 1. And x equals negative 3. So now I have an x and a y, but my answer to my system is the point at which the lines intersect. So my answer is a point. So my point is negative 3, 3. Remember, x goes first. Alright, that's called elimination. Let's try another one. Number 2, so we want to look, do we have any variables that will eliminate? So we look at the y's. The y's are, the coefficients are 3 and 2. Those won't eliminate each other, or they won't cancel each other out. The x's are negative 5 and positive 5. Well, negative 5 and positive 5 do go away, so that's what we want. So we're going to add our equations. 3y plus 2y is 5y. Negative 5x plus 5x cancel, equals 12 plus a negative 2, which is 10. Okay, now we can solve for y since we eliminated the x. You know you did it wrong if you still have x and y in your same equation, because you can't solve it when it has two variables. Okay, so you get y equals 2. Once you solve for one of the variables, in order to solve for the other one, you plug it back in. Again, it doesn't matter. This time I'm going to put in the top one, which was 3y minus 5x equals 12. So I'm going to replace the y with a 2. I'm just going to plug in 2 for y. So this is 3 times 2 minus 5x equals 12. 3 times 2 is 6 minus 5x equals 12. Subtract 6 from both sides. You get negative 5x equals 6. Divide both sides by negative 5. Now you can get a decimal if you want, or you can just leave that as negative 6 over 5. Okay, so now I have my x and my y. My answer is the point at which the lines intersect. So my answer is negative 6 over 5, 2. If you did do a decimal, it was negative 1.2. Okay, remember your answer to a system is where the lines intersect. So your answer is the point. It has to be a point, x, y. Let's try one more. solve the system. So we have negative 2y plus 4x equals negative 6. 2y minus x equals negative 9. My y's cancel because they're opposite. They are the same number but different signs, so negative 2 and positive 2. So we're going to add these equations. So negative 2y plus 2y cancel. Positive 4x plus a negative 1x makes 3x. Negative 6 plus negative 9 is negative 15. Divide both sides by 3. And you get x equals negative 5. Okay, I got my x value. Now what I need to do is plug that back in. Okay, I put it into either equation. Doesn't matter, I'm going to put it in the top equation. So you get negative 2y plus 4x equals negative 6. I'm going to replace the x. I'm going to plug negative 5 in there. So this is negative 2y plus 4 times negative 5 equals negative 6. So negative 2y, 4 times negative 5 is negative 20 equals negative 6. Add 20 to both sides. You get negative 2y equals negative 6 plus 20 is 14. Divide by negative 2. And y equals negative 7. Okay, so I have my x, I have my y. I cannot leave that as my answer. My answer is the point at which the lines intersect. So my answer is x comma y. So negative 5 comma negative 7. So if I was to graph those two lines, they would intersect at the point negative 5, negative 7. Okay, so that's the first day of elimination. Make sure you wrote all those notes down. Okay, if you did, tomorrow will be easy. We'll see you tomorrow.